Hey everybody. Yeah, I'm Richard. I'm a front-end engineer or UI developer or creative technologist or senior webmaster. I'm really not even sure anymore. I'm originally from New Zealand. I don't speak a word of Russian, so I'm just kind of wandering around today just smiling politely. I have no idea what's going on. So if you see me just looking confused, come say hi. But yeah, the last 8 years or so, I've been living in London, and I've been working with interactive dataviz for most of this time. I work at a company called Quantum Black, which is part of McKinsey. Now, I know the company name sounds kind of sinister, but we're actually a completely legitimate organization. We have a bunch of different offices around the world, like this is our new Japanese office. And here are some of my friendly coworkers. You can see we're a diverse team. And this is my boss. He's a big animal lover. So QB is an advanced analytics company, and we do a lot of fancy things with data. I work with a lot of smart people with data in their job title, like data scientists and data engineers and dataviz designers and developers. And my job is to take this data and translate it into an interactive chart-based tool or product that will help them explore it or explain their insights to clients and stakeholders. So I'm going to talk to you today about how to make great charts in the browser. But before I begin, let's begin with a story. To set the scene, I want you to imagine it's 1854 and you're in Victorian London. At this time, London is the largest city in the world. It's arguably the global political and financial capital. Fortunately, nobody's talking about Brexit yet. Meanwhile, the British Empire is fighting Russia in the Crimea, not too far away, and author Charles Dickens is an international celebrity. London is suffering from one of its worst ever cholera outbreaks. The disease has ripped through Soho, killing over 600 people and causing many of the local residents to flee the area. At the time, there were two competing theories on the cause of cholera's spread. Some people argued that it was spread by rank-smelling air, or miasma, that came out of rotten, decaying matter. Meanwhile, others said that it was spread through some sort of unidentified microscopic organism, or germ. If you've heard of germ theory, but you haven't heard of miasma theory, then at this point you might have some idea which one was right, but please don't spoil it for your less observant neighbors if they haven't worked it out yet. Now, every good story needs to have a hero, and this one is no exception. He was an English physician and a skeptic of miasma theory, and his name was John Snow. Not that one, that guy. So John Snow didn't understand exactly how cholera was transmitted, but he knew how to read the evidence, and he didn't like the foul air theory. He reckoned it was spread through the water supply. By chatting to local residents and studying the pattern of how the disease spread, he identified the source of the outbreak as the public water pump on Broad Street, basically just here. Actually, just a few minutes walk from my office, which is just down here. So John Snow tried to warn everybody about this pump, but they told him, "You know nothing, John Snow." But he was eventually able to convince the local authorities about his theory with the aid of his dot map, which illustrates the clusters of cholera cases juxtaposed with the locations of water pumps. You can see on the map how the infections are concentrated around the Broad Street pump, marked in blue in the middle. Once he convinced the parish authorities that almost all the deaths occurred at houses which were a shorter walking distance to the Broad Street water pump, they solved the problem by removing the pump handle. This forced people to draw water from other wells which were not contaminated, and the number of new cholera cases fell. So what does this tell us? Firstly, not to drink the water from public taps in Soho. If you're in any doubt about this, you should know that not one of the employees at the brewery just up the street from the pump contracted cholera. That's because they were paid in beer, so they didn't drink the water. So if in doubt, don't drink water, drink beer. There's actually a pub on the location of the former pump called the John Snow, and you can drink your beer instead if you come visit me in London. Secondly, that a well-executed chart can inspire action. John Snow's use of a map-based dataviz helped convince the city to shut down the infected whale. His chart might have saved hundreds of lives. But thirdly, and most importantly, it tells us that a good chart should have a story. Most data visualization is done for the purpose of visualization, of communication. We have an insight about a data set, and we have a potential audience, and we would like to convey our insight to our audience. To communicate our insight successfully, we'll have to present the audience with a clear and exciting story. Now, the need for a story may sound a bit disturbing to engineers who may equate it with making things up, or putting a spin on things, or overselling results. After all, surely the point of a chart is to persuade people with cold, hard numbers, not wishy-washy emotions. However, we must not overlook the important role that stories play in reasoning and memory. We get excited when we hear a good story, and we get bored when the story is bad or when there is none. So when you want to make a chart, the first and most important thing to think about is what point your chart is trying to make, or what problem you're trying to solve. Are you trying to persuade people and change their minds? To teach them something new? Or do you just want to make some dank chart-based memes? So next, consider who your audience is. Is this a dashboard that they use every day at work? Or will they be random Reddit users? If it's the former, then they can afford to spend more time learning to use a complex interface. You also want to consider their level of education and technical ability. Like, are they data scientists with PhDs? Or are they teenagers? How familiar are they with complex web user interfaces or with common chart metaphors like axes? All of these factors will influence how much hand-holding you'll need to do for your users. There's often a balance or a trade-off to be made between intuitiveness on the one hand and originality on the other. Now, my favorite thing about charts is their ability to tell a compelling story in a beautiful way using just a few kilobytes of data and code. And just as most good storytellers use metaphors, good dataviz uses metaphors too. Like, you can represent data in your visual stories with properties like position, shape, size, color, line width, and line type. All aesthetics fall into one of two groups: those that can represent continuous data and those that can't. So continuous data values are values that have arbitrarily fine intermediates. For instance, distance is a continuous value because you can break that down into as many intermediates as you want, for kilometers down to nanometers. On the other hand, number of persons in a room, like this, is a discrete value, because a room can hold 5 people or 6 people, but not 5.5 people. You can use position, size, color, or line width to represent continuous data, while shape and line type should usually only be used to represent discrete data. Each of these can have advantages and disadvantages for different types of data. For example, size could be misleading because it's tricky for the human eye to accurately tell how much bigger one thing is than another, while certain color scales don't work well for colorblind people. So you want to be careful how you use these scales. By the way, we've discussed static visual aesthetics, but you don't just have to stop there. Instead of paper and ink, we're using computer screens, CSS, and JavaScript. So you can use time as a medium too. Consider playing around with animation, like you can use frequency or velocity as a metaphor as well. Speaking of which, I just want to give a very quick photosensitivity warning. If you're strongly affected by flashing images, then I'd recommend looking away just very briefly. So with that out of the way, sweet. So in 2015, I was working with a creative team making interactive web content. And we did this piece about this hot new app called Snapchat. At the time, it was growing really quickly, and it was amazing to think that there might be nearly 9,000 photos being shared per second. We wanted to impress upon people just how many photos this was, and so we visualized it by using the Snapchat logo and emojis to represent each photo. And we thought it was pretty effective, and it did okay on Reddit, but that many photos per second was a lot for most computers' GPUs to handle. Like, if you came up and listened to my computer right now, it's getting pretty hot. But predictably, the frame rate suffered on all but fairly powerful computers. And mobile phones did not handle it at all. It was just a disaster. It was a good learning experience about performance limits on different devices. By the way, the number of Snapchats being shared these days is close to 34,000 per second, which would probably be enough to completely ruin the frame rate for everyone, no matter what computer they're on, if not completely crash your browser, which this does occasionally to me. But that was a fun project, but you can use animation in more subtle ways to communicate about your data as well. And this is done really well in one of my favorite apps. Dark Sky is a smartphone app that does hyperlocal weather forecasting to predict exactly when it's going to rain in the next hour by cross-referencing your phone's GPS against local weather data. It's amazing for working out whether you need to bring an umbrella when you're about to step out to go for lunch. But before you all download it at once, I should warn you that unfortunately it only works in the US, UK, and Ireland, so sorry about that. Really hope it comes here soon. But Dark Sky uses an area chart to show when and how it's going to be raining over the next hour. And the developers have included this cute little wiggle animation, which I think is great for communicating the level of uncertainty in the data. And I think it's really clever. So we have a few different aesthetics that we can use to represent our data. But before you start visualizing it, you need to consider what sort of data you're going to present. You might think of data as numbers, but numerical values are only a couple of the many different types of data we encounter. In addition to continuous and discrete quantitative values, data can come in the form of discrete qualitative categories, or dates as times or as text. In order to translate your data into a visual aesthetic, you're going to want a scale function. Scales are your basic low-level building block of any chart. They make it easy to take data of different formats and convert it consistently into a corresponding aesthetic value, like a pixel distance, or a color, or a shape. Importantly, a scale's input and output must always have a deterministic one-to-one relationship. So for each specific data value, there should be exactly one aesthetic value, and vice versa. If a scale isn't one-to-one, then the visualization can be ambiguous. So to set up a scale function, you'll start by providing an input domain and an output range. The domain is the complete set of data values that the function can expect to receive, and the range is the set of aesthetic values that you want it to return. So for this slide, I'm using a linear color scale to set the background color based on the mouse position on the screen. So if I move up and down, you can see the background change. We have a continuous numerical domain, which is based on the screen height. The input value is set from the current Y position of the mouse as I move it around. Our output range is using the hue of an HSL color, which goes from 0 to 360. As you can see the aesthetic output on the screen background there. So now it's time to choose a chart type. There are hundreds of different established formats, and each has different advantages and disadvantages for different types of data. The most important thing, though, is that you choose a chart type because it's the right type for your data. A couple of years ago, I did some work on a client project with a team who asked us to make a bubble chart. We asked why they wanted a bubble chart specifically, and they said, it's mainly because the client likes bubble charts. You can show a lot of different dimensions at once on a bubble chart, and it's what they've always used. And so the client has grown to expect them, and so we built it for them. And I think it ended up being like a really good bubble chart, but had lots of filters and animated transitions between states and so on. And the client was impressed and the team were happy. But I can't help thinking that we were going in with one arm tied behind our backs, and that we could have chosen a chart that would have communicated so much better if we'd been allowed more flexibility to choose a chart that would suit the data set. So above all, if you learn nothing else from this talk, I want you to learn from my mistakes and don't do what we did on that project. Instead, remember that you should choose your chart style based on your data type, the problem you're trying to solve, the story you're trying to tell, and your audience. And this is a hard problem, but fortunately there are loads of tools around to help you out. I've listed a few here, and I'll tweet out some links to them later on. There's a few links at the end of the slides. I'll post them up. But each one of these is slightly different, but they all have a common starting point, which is to ask yourself, what are you trying to show? Are you trying to demonstrate a correlation between variables, or a size comparison, or maybe how something changes over time? Find the thing that you're trying to present and work from there until you've found the right chart for your data story. Okay, so once you've chosen a chart type, now it's time for the fun part, like building the chart. But we've still got so many options to choose from, like which web technology will you build it in? The most common choice is SVG. I spend a lot of my time working with SVG, and I often assume that's a core part of every front-end developer's toolkit. But I meet a lot of devs who haven't really worked with it much, or don't feel confident writing from scratch. And if that's you, that's cool. So here's a lightning summary of SVG. SVG is basically an alternate universe version of HTML focused on graphics instead of documents, where everything is set to position absolute. You get some new element types like circles and polygons and lines, and you have to use a bizarro world version of CSS, which has features like stroke and fill, but you can't use most of the regular useful features you'd use, like background image and border and box shadow and things like that. Also, weirdly, text won't wrap automatically, which is way more annoying than it sounds. So you have to use JavaScript to calculate text wrap with weird hacks like injecting it into the DOM, then measuring the text width, then deleting it, and then re-rendering it with extra tags inserted to add line breaks, and it's basically a nightmare. SVG has a DOM, though, just like HTML. So it's not great for JavaScript animations on large numbers of elements because you can get tired with that. But you can use CSS animations, which are super performant. And so I try to use those over JavaScript animations wherever possible. Also, SVG is vector, so it scales well. So you can make it huge without sacrificing image quality, even if the result is extremely upsetting and you start to wonder why you did it in the first place. I'm so sorry. I'm going to move on from that. So next up, Canvas. Canvas is often used for visualizations, which have a large number of animated nodes, like force-directed network graphs. In practice, writing to Canvas is a lot like using Microsoft Paint, but with JavaScript. Anybody here used to mess around with creating weird images in Microsoft Paint? See a few hands going up, yeah? An old flatmate of mine used to use my computer to do these weird pictures in Microsoft Paint while I was out, and then set them as my desktop background. And then I'd just get home and turn on my computer and just be like, what is this? If you've used Paint, then you'll remember that in Paint there are no layers or objects. If you draw over something, then it's gone forever. HTML Canvas is the same. Everything is raster, and there's no DOM. There's just a great big area that you need to paint onto. The native JavaScript for writing Canvas tends to be a lot more imperative than writing SVG, which can make it a lot more time-consuming to work with. You also can't inspect any DOM elements or attach mouse events to objects because there aren't any. All of which makes it sound like a massive pain, which it kind of is. But it's really performant for complex animations with lots of different elements. If you loaded 8,000 different DOM elements and animated them all with JavaScript, like that Snapchat one before, your frame rate would drop through the floor. But you can do it with Canvas, and it's relatively OK. Because there aren't persistent objects that you can move around like you would in HTML or SVG, you need to repaint every single frame from scratch. To illustrate this, here's a little example I've made, which has loaded a JPEG file, and it's just moving it a little bit every frame and drawing it again and again. If you let it run, the canvas will fill up with old copies of the image, which would cause all sorts of performance issues if this were HTML images. But it's Canvas, so it doesn't matter. It's just pixels persisting until you draw it again. But you normally don't want to leave a trail every time you move something on screen. So usually, what you'll do is erase the entire canvas and redraw it again from scratch every time you request a new animation frame. So we've looked at Canvas in a 2D context, but it also has a 3D big brother, WebGL. WebGL is basically Galaxy Brain Canvas. Like it is to 2D Canvas what 2D Canvas was to everything else, but even more so. If you think Canvas is performant, well, WebGL is even more performant. Do you find Canvas tricky to write sometimes? Well, WebGL is an absolute nightmare. Consider the following example. I've shown examples of SVG and Canvas code. So this is like a relatively straightforward hello world demo from the Intro to WebGL tutorials on the Mozilla Docs website. So let's quickly read over the code and see if we can figure out what it means. So we're initializing our canvas in WebGL context, setting up some shaders for vertices and fragments, handling lightning sources, creating some objects and buffers, loading textures, drawing the scene. It's still going. Oh no. Everybody got that? Sweet, cool. Anybody else able to work out what that makes? Yes. So, yeah? Yes, correct, a cube. Prize to that man. Yeah, the answer is a spinning cube. So for that reason, I don't think many people actually write native WebGL. You're better off using a library like 3JS, which is what I use to code this lovely spinning bar chart. I use this example to raise a very real issue with 3D charts, which is that most of the time, they're completely gratuitous and don't add anything useful. In fact, by projecting data into a third dimension, then representing it on a 2D screen, you're introducing visual distortion. Our eyes can try to correct visual ambiguity, but we can only do so much. Much like all those crappy clip art looking 3D pie charts generated with Microsoft Excel for early 2000s PowerPoint demonstrations, many WebGL charts are gratuitous decoration that do nothing to help the viewer understand the data. So I'd avoid them if at all possible. The best exceptions to this rule are visualizations of actual 3D objects, like topographical maps with mountainous terrain. But in this case, you'll still want to allow users to rotate the view to reduce the distortion effect by providing different perspectives. And last but not least, let's not forget about HTML and CSS. You can totally make charts using just HTML elements. HTML is great for making simple bar charts. You can make use of the normal document flow to arrange them without needing to calculate each bar's vertical offset. You already know HTML and CSS, so there's no learning curve, really, and you can use CSS for animations. Also, HTML makes it easy to write semantic and accessible markup compared to Canvas, which is basically a great big black box. The downside of HTML is that although there are lots of shapes and layouts that you can achieve with SVG, with CSS, ultimately it's not as flexible as SVG and Canvas. So I recommend saving it for things like prototypes and Spark charts, and using SVG and Canvas when you have a more complex chart in mind. Right, so we've figured out what technologies we can use. But you probably don't want to build it completely from scratch, right? Other people have done this sort of thing before, so there's no need to reinvent the wheel. But this can be a tricky decision too, because there's so many charting libraries to choose from. There are loads of popular ones out there like HiCharts, and Chartist, and Chart.js. And there's a bunch that use D3 with React, like Semiotic, and Victory, and ReactViz, and Recharts. And there's also dozens that are just reusable abstractions for D3, like Plotly, and C3, R2D3, NVD3, RJD2, D20, C4, and R2D2. It's overwhelming. But these libraries typically provide just a few basic chart types and abstract away most of the complexity. Whether this is a help or a hindrance depends on your use case. But some of you might be wondering about D3 and why I didn't include it in this list. D3 is a data visualization library too, in a way, but unlike the others, it's much more low level. It's a bit more like jQuery or underscore than a chart library in the sense that rather than giving you ready built charts or chart components that you can configure, it gives you the tools to build your own custom charts from scratch and a sort of set of best practices you can follow. And in fact, the syntax looks a lot like jQuery too, so if you love method chaining, you'll love it. D3 is designed to enforce separation of concerns between data and presentation, just like the web was designed to with HTML and CSS. And I know that's not quite such a popular idea lately with CSS in JS, I know, but I reckon it can still be a useful model at times in the right context. So instead of asking which library I should use, the real question ends up being, should I choose D3 or a charting library? And this one really depends on your situation because each has its own set of pros and cons. For instance, making a chart with a charting library is typically much quicker than writing something from scratch with D3. That's the whole point. They're an abstraction that saves you having to repeat the same basic steps every time you make a new chart. But when it comes to power and flexibility, that's when D3 can really dance around the competition. It gives you full control over how things look and has so many different tools and algorithms so you can mix and match to create really cool effects. I've been working with D3 for many years, and I still regularly come across things where I'm like, whoa, D3 can do that? It's awesome. It also works seamlessly with existing web technologies and can be used in conjunction with other tools and frameworks. You can manipulate any part of the DOM or use it with SVG, Canvas, WebGL, or whatever. By contrast, most charting libraries are fairly opinionated, so they don't always do everything you want them to. If you have a specific design in mind, then the abstractions they've chosen may not fit your use case. I often find that it's not until I've nearly finished building the chart that I discover the limitations of a given library's API and realize that it's not able to implement certain quirks of the design that I've been given. So then I have to start all over again in something else. So what I sometimes do is make a basic prototype in a charting library, then build a more fleshed out version in D3 once I've got more time to invest. But when it comes to the learning curve, that's definitely a downside for D3. Most charting libraries are designed to be fairly easy to get started. Often you just need to modify an example config, and then it's pretty intuitive in your way. Whereas D3 can take a bit longer to get your head around. I found D3's data binding and element creation to be quite tricky to understand when I was first getting used to it. First, you need to create a new selection, so select all the DOM elements on the page, but they don't exist yet because you haven't created them. Then you have to enter them, which means specifically selecting the ones that exist in the data, but that don't exist in the DOM. Then you append DOM nodes to the selection, and only then do you create them on the page. And it made sense once you understand what they're trying to get at, but it just did my head in when I was learning it. Now, when it comes to performance, whether animation performance or download size, that's a bit of a mixed bag. I found that some charting libraries I've used can be a bit janky at executing complex animations, but it really depends how far you're pushing them beyond what it was designed to do. Whereas D3 usually pretty great for animation and makes it surprisingly easy to do some really cool transition effects like staggered delays. And you can use CSS animations with it too really easily, so that's really cool. In terms of download size, it really depends on the library. If you only need one bar chart, you have to include the whole kitchen sink. That's obviously not ideal. D3 used to be the worst culprit for this. It has dozens of different APIs, and if you import the whole thing, it's about half a megabyte unminified. But as of version 4, it's now completely modular, so you just import the bits you want. When? And next up, code readability and maintainability. This depends on the library and your preferences. And I'd say code beauty is a little bit in the eye of the beholder. But I think most of us would agree that D3's more imperative code style and chain functions are a bit more complex to understand, which means you need to put a bit more thought into documenting them and avoid writing sprawling spaghetti code. Most libraries are going to beat D3 on this one. And finally, popularity. D3 is far more popular than other JavaScript charting libraries, at least if you're going by GitHub stars. It has a huge community and loads of examples, tutorials, Stack Overflow questions, demos, and even a few books written about it. I know that was a lot of information for one slide, so here's a quick summary. If you just want to do a standard chart type, like a bar or line chart, and you're not fussy about the details, coding in D3 will take longer than using a charting library. I recommend to use D3 in situations where you're just trying to implement an unusual design as quickly as possible, closely as possible. I mentioned that D3 plays around well with other tools, and that includes React and other JavaScript frameworks. But when using them together, you have to make a big decision about what to use for updating the DOM. D3 is still perfectly fine to use for layout calculations, even if you use React for all the DOM rendering. And in fact, out of D3's 30 different modules, 22 of them don't have any API methods that come in direct contact with the DOM. So it's fine if you want to just use React, but they're both great for DOM rendering in their own separate ways, and each have their own advantages or disadvantages. D3 is amazing for handling animations and has some really useful SVG helpers for tricky things like axes. But D3 code tends to make your chart less structured by putting the whole chart in one component, which can lead to tight coupling between individual parts. It's also a bit less readable than React's declarative syntax. It's a pretty tough call. I like the structure and readability that comes by using React components, but I also like using the transitions directly on the DOM elements. So why not choose a hybrid approach? What I like to do is combine both approaches. Let React render static components and use D3 for axes and anything that needs complex animations. You can mix or match the syntax together, see what works for you. Finally, you don't have to just use your new D3, SVG, and Canvas knowledge for making charts. D3 is not just a data visualization library. It's a data analysis library, a data formatting library, an SVG shape library, an animation library, and a DOM manipulation library. It has dozens of different modules and algorithms to play with, and you can get really creative with them and mix and match different layouts and scaling functions to create interesting effects in different contexts. They're great for adding playful flourishes to your websites or your tug slides. Thanks. If you have any
questions.
Okay, first of all, thank you for your speech.
Thanks.
It's a kind of trendy topic today. However, I often see cases when developers are using too many probably properties to differentiate data in the same chart, like shapes, colors, positioning. They're putting this just in the same chart, and because of this, it becomes, let's say, not so easy to read to the user. So my question is how to understand if your chart is not easy to read for the user, and how to avoid this at the stage of development.
Okay, thanks. Great question. So I think with these, when it comes to making sure your chart is easy to understand, I think user testing can go a bit long way with that. So if you can try and find some of the users and interview them, especially someone who's brand new to the chart, try to find someone who reflects your user group but is just seeing with the chart with fresh eyes. Because I find often, once you've been staring at something for a long time, stuff starts to seem really obvious, but someone coming new to it, just it looks really silly. There's a lot of charts that we've used at work which I think are really non-obvious, but because they're being used by someone on a day in, day out basis, as at work, they're people are pretty used to them. So there's often that trade-off. If people are using it at work, like I said, that can be fine for having something that's a bit less obvious. But if you just want to catch people's attention and make them understand it right away, then I think often you want to fall back on a more established chart type. In terms of using lots of different types of shapes and colors and different things like that, I usually would try to avoid trying to be too clever. I think there's ways of doing it, but you've got to be really careful. It requires really skilled designer to be really, really clever and think outside the box in that way, because usually if something works, someone's done it before. So I often tend to try to use a lot of different types of charts and maybe make a dashboard of lots of different types of charts together, each showing different aspects, rather than trying to concentrate it all on one chart where it can end up being a bit of a mess. Yeah, hope that helps.
Okay, great, thanks.